Hey everyone, Fred here from AF Math and Engineering, and we're doing a video for you, another one on the moment distribution method. This one is going to cover a continuous beam where we have a fixed end on one end, roller support in the middle, and then on the other end now we have a roller support. So in the first video we did our explanation video, you had a fixed support on the end too. So this video is going to highlight how to transfer the moments or carry over the moments between two roller supports. And there's a faster trick way to do it using the modified stiffness method, but we're just going to focus on the regular stiffness, and so that's a little bit longer, but it'll give you some understanding, and then in another video we'll cover the trick. So the question is asking us to calculate the member and forces in the beam, as it usually does in the moment distribution method. We have E as constant, and one thing to note here is that we have 1.5 I for the section AB and I for BC. So let's start by finding the k's. Okay, so we have our k factor for AB. Okay, that's simply I over 10. And let's not forget the 1.5 on the numerator there. Okay, don't forget that. That's an easy mistake to make. And then we have KBC of I over 10. Okay, so our distribution factor for the left side of B is going to be the KBC of the side of the support that we're doing divided by the sum of the members, or the sections of the member to the left and the right of B. Okay, we know that the distribution factor at a fixed support is 0, as we went over before in the other video, and we know that to the left of the hinge support on the right side, or sorry, on any end side, so if the beam ends at a roller support, the left side of that or the right side of that is going to be 1. Okay, and then the other side is simply 0 over here, which we don't write. So let's go ahead and find the distribution factor for the left side of B. And that's simply going to be 1.5 I over 10 over 1.5 I over 10 plus I over 10. And that is, if you put that in your calculator, going to be equal to 0.6. So we're going to go ahead and fill that in here. As we know, the summation of the distribution factors needs to be 1. So if we do 1 minus 0.6, we're going to get a distribution factor of 0.4 for the right side of B. And now we can go ahead and start filling out the table. So if you'll remember from the first question that we did, okay, the first step is to find the fixed end moments. Okay, so calculate the fixed end moment for AB and BC. As we always do with these questions, I'm going to let you do that. Fixed end moments chart is up on the screen for you to try on your own. Just take a minute, do it by yourself. Okay, it's just plugging in formulas. It's good to do, but that's not why you're here. So I'm going to write the initial fixed end moments in for you. Okay, so we have 100 kilonewton meter, negative 100 kilonewton meter. To the right of AB, left BC, we have 50, and to the right we have negative 50 kilonewton meter. So as we know, the second step, we're going to need to balance that joint at B and C. So we're going to balance the joints at B and C. Okay, so now what do we do? Well, if we remember from the question before, we're going to take the summation at the joint of the fixed end moments below it. So we have negative 100 plus 50, and we're going to multiply by the distribution factor on the left and then on the right. And when we do that, we're going to change the sign. Okay, so negative 100 plus 50 times 0.4, and then times negative 1. Okay, because we change the sign, that's going to be 20. Okay, as you can see, there's no balance here. This joint is multiplied by 0. This one, however, okay, this joint, and this is kind of the trick, and this is what separates this from the other question that we did, is that now that C is an end hinge support, okay, we have a 1 distribution factor here. So we're going to multiply that by 50. We're going to get negative 50, change the sign, that's positive 50. Okay, now we do the carryover. So let's start with the carryover. Okay, now remember, we went over this before. When we carry over to a fixed support, okay, or to a hinge support, we're going to carry over half the moment. Also remember that when we carry from a fixed support, there is no carryover from a fixed support to a hinge. So when the moment gets transferred to the fixed, it stays. Okay, so that's what we're going to start with. So we're going to start by transferring this over to here, and we're going to take half, remember. So half the moment gets transferred, and we're going to transfer this, carry over that moment, half of it. Now, this is what differs from the other questions. We need to carry over from C to B, okay? Because C is not a fixed support. C is a hinge. So that needs to come over here as well, and half of it needs to come over. All right, so now in the last question that we did, the easier question, we finished at this point, but now we're not finished because, as you can see, there are values under the joints that that we need to balance. So we need to continue with the question until these values that are under the joints get so small that we can kind of say that we're finished. Okay, because otherwise we'll pretty much be going forever. So let's go ahead and let's just repeat step two. Okay, where we balance joint B and C. Okay, so balance B and C. Okay, so what we're going to do, we have 0 here and we have 25. Okay, so we're going to add those together, 0 plus 25, and we're going to multiply by the distribution factors just like we did, and then we're going to change the sign. So we got 15, that's going to be negative 15. Okay, so 25 times 0.4, and that's going to be negative 10 here. And then we have the 1 again, so 1 times 10, change the sign, negative 10. And you just continuously repeat this step. Okay, negative 7.5. And this is going to, and remember, the fixed doesn't transfer, only the roller transfers to the fixed, and then the fixed takes all of the moment there, okay? It doesn't transfer it back. Same with this. B is going to transfer over to C, carry over, and that's going to be half. C is going to transfer half over to B. That's negative 5. And now we can just continue, okay? So doing exactly the same thing. Let's go back to the middle joint and start to balance. Okay, and then that just repeats. So once you get to this step here where we're transferring in between these roller supports, you carry over, then you balance the joint if there are still values here, carry over, balance, and you just continue that until the numbers get small. I would ask your professor when to stop, because as you'll see, these numbers will get smaller and smaller and smaller. For example, if it's like, smaller than 1 or something like that, they may tell you to stop. So let's just go through this pretty quickly. So we have negative 5. Okay, that's going to be times 0.6. So we have negative 3. That's for the left side, right? So change the sign. That's positive 3. Okay, negative 5 times 0.4. That's going to be 2. And then positive 5 here. Okay, so negative 5 times 1, change the sign. Let's do our carryover. So we're going to carry over this. Okay, so we're carrying over 1.5. Okay, positive. We're carrying over half of 2 to C. That's going to be 1. We're carrying over half of 5, which is 2.5. Okay? And let's just continue. So 2.5, let's keep balancing. 0.6, that's going to be negative 1.5 here. Okay, 2.5 times the distribution factor. Change the sign, negative 1. 1 is going to be multiplied by 1. Change the sign, negative 1. Do our carryover again. As you can see, you can start to, take half of 1.5. So that's going to be, we'll say negative 0.8. We'll round up. And we're going to take half of this, carry it over, half of this, carry it over. That's negative 0.5. This is negative 0.5. Okay, and now you can see you start to get into a little bit of a rhythm, okay? And if you want to write these steps out all the way down, that's fine. And now, as you can see, our numbers are getting very small at the balanced joints. They're getting very, very small. They're not really contributing to the end value that much. So, like I said before, ask your professor. We're going to do maybe 1 or 2 more, just so you can kind of see what to do here, and then we'll stop. Okay, so that's 0.2. We're going to, for the 0.4, this side, okay? Negative 0.5 times 0.4, change the sign, 0.2. Okay, negative 0.5 times 0.6, change the sign, 0.3, positive. This is going to be positive 0.5. Negative 0.5 times 1, change the sign. All right, and now we simply carry over again, okay? And this is going to be half, so 0.15. Okay, this is going to be 0.1, half of 0.2. This is going to be 0.25. All right, and now we can go ahead and let's just balance the joint once more. Okay, so we'll say 0.25, or we can round it up. We can say 0.3 times 0.6. That's going to be negative 0.2. Change the sign, negative 0.1, and finally negative 0.1. Okay, now as you can see, we're at very small numbers now, and we're going to stop balancing. We can say that these joints are balanced because these are almost equal to 0. And now we can go ahead and simply add up all of these columns. All right, and you should get values of, so if I add all of these up, taking the signs, we're going to get 108.4, negative 83.4, 83.4, and 0. So remember what I said before, these two moments at the end, at the joint, the summation of the moments, all the moments acting on B must equal 0 because it's a roller. If you get like slightly different numbers, due to rounding, then that's okay. But if you're way off by like 1 or 2 kilonewton meters, that's not okay. And finally, we're going to end up with 0 at the roller support, which makes sense, okay, because at the end, the summation of the moments needs to equal 0. So let's go ahead and finally draw out the moments. So if we take a look at A, B, B, C, okay, we're going to have a positive moment of 108.4. Okay, that's going to, and really what you're going to have to do is review your sign convention when you're drawing, cut beams and which one's positive, which one's negative, because that can also get you. Okay, so we have a positive moment here. We know our sign convention is positive here. Okay, if we're looking at it from this side of the beam, we have a negative moment here of 83.4. Okay, we have a positive moment here of 83.4, and we have a 0 moment there. So that's pretty much it. I've gone ahead and I've just labeled the free body diagram there. That's it for our moment distribution method question. I hope that kind of clarified how to transfer moments between roller supports like that. In another video, we'll do the modified stiffness where we can avoid that, but it's important to get that concept down, balancing the joints until they reach 0, and being able to draw the free body diagram from the moments. Thanks for watching, guys, and as always, like and subscribe.